Hello everyone, it's time for my second official devlog for my upcoming pixel art game Nanoplanet. If you want to know more about who I am and the inspiration for this game, check out the devlog playlist here. But for now, I'll give you a quick recap on what my game is about. My indie game Nanoplanet is about Earth experiencing an apocalyptic event due to climate change and a crew of astronauts, or as I call them, nanonauts, that leave Earth to find a new home planet. The crew flies through a wormhole and crashes on a destination planet. Then you, the main character, wake up to find out that the planet isn't as hospitable as you once thought. You will then go through a series of quests to awake your crew members from their cryo chambers, explore the planet, meet the alien civilizations, learn their language, and help save the planet. I like to think this game is a lot like Stardew Valley, but instead of taking over a farm and the antagonist being Jojo Mart, you're terraforming a planet and the antagonist is climate change. Now that you know what this game is all about, let's dive into the features I implemented this devlog. The main focus of this devlog is adding alien animals to my game, but the first thing on my to-do list since the last devlog was to perform some code cleanup and optimizations. I plan on doing this after every devlog to ensure that my codebase doesn't get too unruly and my game stays performant. Once that was finished, I had to wrap up some small kinks and bugs with the farming system I implemented last devlog. Then I finally got to work on some new stuff. The first new thing I worked on was adding water, because after all, if a planet doesn't have water, is it really habitable?
What kind of place is this? There's no water in here.
So I drew up some animated water tiles and implemented them using Unity's 2D Extras animated tile class. Now that I have water in the game, I redrew the tiles onto the scene so the player's on an island. The game probably won't stay this way, but I just wanted to experiment with the new water tiles. I'd like to add rivers, waterfalls, and like a shadowy foreground layer to the game to make the scenes feel a little more atmospheric, but that's for another devlog. Now that the water's in the game, it's time to add the animals to the game. I ended up adding 36 animals to the game. Those 36 animals are split up between 9 breeds and 4 colors per breed. The breeds of animals are dogs, cats, birds, snakes, horse, cows, pigs, sheep, and rabbits. The first step to adding animals to the game was to draw the sprite sheets. This was a monumental task. You may have seen a single sprite of each animal in the concept art from the previous devlogs, but I still had to draw the idle animations, the walk animations, and the interaction animations for each animal in each direction. So if you do the math, that's 4 directions times 3 types of animations times 36 animals. That totals up to 432 different animations that had to be drawn. And each animation has 2 to 4 sprites in it, so I had to draw close to 1,000 frames for artwork for the animals. Artwork for video games is a daunting task, and pixel art is supposed to be one of the least daunting forms of art for video games, which is why it's so popular. So if you're making a video game, don't underestimate how long it takes to do the artwork. Anyways, now that the artwork and animations are created and added into Unity and hooked up to the animation controllers, I needed to add basic pathfinding for the animals. There are various pathfinding algorithms out there, but the A-star pathfinding algorithm is probably the most popular, and I strongly considered using this algorithm. The issue with this is that the player movement isn't locked to a grid, but if I were to use the A-star pathfinding algorithm for the animals, their movement would be locked to a grid. So I did what any insane person would do, and I came up with my own pathfinding algorithm. My algorithm is a combination of an A-star pathfinding algorithm and a ray-based pathfinding algorithm. I'll break it down for you. Picture you have a dog AI in your game. Your dog needs to get from point A to point B. The A-star algorithm would check each surrounding tile and determine if the dog could get to that tile, and then it would also calculate the distance between the dog and the tile and the destination. It would then add those costs together and create a cost based off of those numbers. It will do this for each tile, and then it will determine the tile with the lowest cost, and then it will do the same calculation on that tile minus the tile that it was just on. Now a ray-based pathfinding method is much simpler. It basically performs a raycast towards the destination and determines if it was blocked. If the raycast doesn't hit anything, that means it isn't blocked and the dog will move in the direction of the raycast. My method combines the two. My method performs a raycast by 1 unit in 8 directions and then loops through those raycasts, and if the raycast never hits something, it performs another raycast to the destination, and if that raycast doesn't hit something, then it saves the cost from the distance from the dog to the point and from the point to the destination. It then does this for all 8 positions and determines the shortest cost. Now if there was no raycast that had a clear path from the dog to the point and then from the point to the destination, it will perform the same loop on the surrounding points. I can repeat this process as much as I need, but for performance reasons it's only set to a recursion depth of 3. This means if no paths are found in the surrounding points, it will go 1 unit further and check those surrounding points, and if no paths are still found, it'll go 1 unit further and check those surrounding points. I like my method of pathfinding while still weighing the cost costs from the point to the dog and from the point to the destination, because it's not limited to a grid and it allows the animals and the AI to freely move. It's also very performant. Even with 100 AI pathfinding animals on the screen at once, I'm still managing hundreds of frames per second. Now that the animal pathfinding is out of the way, I need to add the brains to the animals so they aren't just wandering around aimlessly. I really want to have a complex AI system for these animals versus them just wandering from one point to the next. I began researching what makes a good AI in a video game, and I came across behavior trees. Behavior trees are a way to implement AI into video games and have that AI prioritize things in which it needs to focus on, and then have sub actions for each state depending on where it's at in the behavior tree. I implemented this by building a state machine for my AI and then having it determine which state it needs to enter based off an order of preference. So my animal AI currently prioritizes different states like this. First, it checks if there are any predators nearby. Each breed of animal has a list of what their predators are and what their prey are. If there is a predator nearby, it will flee in the opposite direction. Next, it checks if its thirst value is below 50%. If so, it will search for a water source. Then it will check if its hunger value is below 50%. If so, it will search for a food source. I have two types of animals, herbivores and carnivores. If the animal is a carnivore and it's in its hungry state, it will hunt down animals that it thinks are prey and it will take a bite out of them, which fills up its hunger bar and causes some damage to that prey animal. If it's a herbivore, it will just find the closest plant that has harvestable crops on it, and when it eats that plant, it will make the harvestable crops disappear. Next, if the animal isn't by any predators, isn't hungry, and isn't thirsty, it will search for animals of the same species and move closer to them to mimic herding in the wild. Lastly, if there are no animals in the same species nearby, it'll just wander around aimlessly. But if there were animals of the same species nearby, it'll move closer to them, and once it gets close enough, if both of those animals have 80% full hunger, 80% full thirst, and 80% health, they will reproduce and make a cute little baby animal. I'm super happy with how my animals have turned out. They have a non-grid based custom pathfinding solution and complex AI that evaluates if there's a predator nearby, if they need to flee, if they're hungry, if they're thirsty, if there are any animals of the same species nearby, and if they can breed with the animal of the same species nearby. Otherwise, they'll just wander around. I think this will really help my game feel alive. I added these red health bars, green hunger bars, and blue thirst bars above the animals to help me visualize what's going on with the AI. I could honestly just watch the AI run around and interact with each other. It's almost like they have a mind of their own. I plan to have similar complex AI systems for the human and intelligent AI aliens later on in the game. Now that I have animals added to the game, I wanted to add a way for the player to capture these animals. So I created this little ray vacuum gun, I call it a ray vac, and added a particle effect so that when you hold down on the mouse button, it sucks animals in. This tool will suck in any close by animals and add them to your inventory. I then added the ability to place these animals inside your biodome. But now that the player can capture these animals, it needs a way to feed them and give them water. So next I drew up this little food bowl and these water bowls that the player can place down. Then I tweaked the hunger and thirsty states in the animal AI to search for food and water bowls when they've been captured versus still hunting for prey or looking for crops or looking for water tiles when they haven't been captured. Next, I made it where the food and water bowls empty slowly as the animals use them. Now that the animals could empty the bowls, I needed a way for the player to fill the bowl back up. So I added two machines to the game, an animal food processor and a water purifier. The way the animal food processor works is when the player is holding a crop and walks up to an empty animal food processor, they'll be given this little F to interact UI prompt that I added. If they click F, they will place the crop in the food processor and it will convert the crop to animal food. The player then presses F again to pick up the animal food and it adds it to the inventory. They then can walk up to the food bowl with the animal food in their inventory and press F to refill the food bowl. Now the way the water purifier works is very similar. I added fill levels to the watering can and the player can refill their watering can on watering tiles. When the player pours the watering can over the empty water purifier, the machine will purify the water slowly. The player can then press F to add purified water to their inventory. They then walk up to the empty water bowl and press F to refill the water bowl. This is kind of how I want machines to work in my game. No need for complex recipes and crafting tables that the player has to look up the recipes on a website somewhere. Just specific machines that do specific tasks. We'll see how this goes when I add more complex items to the game, but for now it works great. Then I added sound effects for everything that I've added this devlog and some of the things that were missing last devlog. And I also made 3 songs to play as background music. Now that I added more sound effects and music to the game, I decided to add a pause menu that allows the player to change the volume of the sound effects and the music, as well as a save and exit button. And lastly, I added a button to let the player view all the animals that they've captured. I haven't built out the UI for the animal collection screen yet, but I don't think it'll be too hard. Oh, and one last thing. I added the ability for the player to pet all the animals, because what's the point of having these cute little animals in a game and you can't even pet them? Also, when you pet them, it slows down their hunger and thirst decay rates for the rest of the day, so they don't get hungry and thirsty as fast. So there's actually a benefit to walking around every day and petting your animals. Well, that's everything I've done for version 0.2 of my game. If you like where this game is going, or you just love my cringy voice, hit that subscribe button because my next devlog is going to be all about the core gameplay loop of the game. I'll be building out that dopamine hook that keeps you coming back for more. And I'll be giving out a demo so that you can play and give me feedback on what feels good and what needs to be added to the game. Oh, and if you like this video, be sure to hit the like button and help me out with the algorithm. I'm looking forward to the next devlog, and I hope you are too. I'll talk to you next time.